Well, good afternoon. How many of you went to the session this morning with audio and video conferencing with Lync? So I have a saying I learned a couple of years ago that I wish I had learned as a kid, which is the only thing worse than bad news is stale bad news. And so if you're looking for the entertainment and the demos and jokes that you saw this morning, it'll be a little drier than that content. But this afternoon, we're going to talk about concept of high availability and site resiliency. And we'll walk through the different components that we've described at Microsoft or that we've kind of changed our approach, for example, in the product over time, and kind of how and why we've changed that approach or tuned our settings to provide you the capabilities to gain high availability and site resiliency for the Lync platform. The first one we want to point out, and actually new, how many of you have seen the Gartner Magic Quadrant report from 2011, the one that just came out? So a few hands going up. First of all, we're happy to announce that, again, for several years in a row now, Microsoft is at the highest corner in the quadrant, so in the Magic Quadrant. We are still the leader in the UC category from the Gartner side. I don't know if the Gartner reports are as impactful in Australia as they are in the US, but it's one of the areas that we take great pride in. We really strive to get both the product adoption numbers as well as the vision and leadership numbers that Gartner is looking for when they compile that report. So all this year we were kind of eagerly anticipating it. We shipped Lync last fall, and we were hoping that a lot of our customer voice momentum helped carry or continue our leadership in the UC category. And the thing we point out here, right, is that we started, if you saw this morning, we talked about the concept of the VoiceCon or the Enterprise Connect RFP and how that we've continually improved and iterated the versions of OCS or LCS, OCS, and Lync to gain the UC capability specified there. What we're seeing now is that adoption of Lync in numbers. When we first started shipping voice back in 2007 with OCS 2007 RTM, it took us about 4 years to get to 1 million seats of people running enterprise voice on top of Office Communication Server. By June or July of last year, we hit that first 1 million threshold. So about 4 years for that to come into play. In the past 12 months, we gained another million rapidly on that. So we saw a much faster uptake in terms of putting actual users on a voice infrastructure running on Lync based on what we saw with those previous versions, both and what we believe is primarily due to a lot of the changes in the product that we're going to talk about this afternoon, or really the capability of having a software PBX that can run at that high workload, high level of availability that users have grown accustomed to essentially in their current voice infrastructure or their telephony infrastructure. And this really runs the gamut. We see customers as small as 50 to 100 users. We see customers in the tens of thousands of users deploying Lync for voice. A couple of the customers here are in the 30 to 40,000 range. We've moved approximately 95,000 people internally onto Lync for our voice platform essentially. And so we have number volumes now in the size that was not the case if we go back 3 or 4 years, and are running those at high levels of availability and the capabilities that you saw, for example, in this morning's session. So let's talk a little bit about the concept of high availability and site resiliency. We really break that out into 2 areas because we tried to separate them at Microsoft. It goes by a lot of terms. People will talk about the overall availability. They may mention 3 nines, for example. They may talk about disaster recovery plans or business continuity plans. And what we really try to do is define the 2 terms, high availability and site resiliency, in a simple or easy to understand aspect. If you have a single data center, services being provided in that data center are highly available. So high availability addresses the concept of us being able to recover from a server outage, a network outage, a power failure, a localized issue affecting a single data center. When we talk about extending services beyond a single data center, now we start talking about the concept of site resiliency. So now we're saying if we have a power outage that affects the entire data center or a network outage at the data center, now we're stretching or we're going beyond what we would cover in high availability, and we're using probably a different method for achieving or obtaining this concept of site resiliency. That may be automatic, that may be manual. Typically there's some sort of manual intervention required to activate services, for example, in a different location. And that also is going to impact of whether both locations are hot or cold. We may have a hot data center and a cold data center. We may have 2 data centers both providing services, but each sized to accommodate or handle the load in the case of a single data center failure. We also have more than just this concept of high availability and site resiliency when it comes to voice around the concept of a branch office. So with other versions of Microsoft products, so if you look at the concept of a SharePoint or Exchange for mail, for example, we have the capability of hosting services centrally, and there is an implicit assumption that if the WAN connection is not available from a branch office, that functionality will not be available for users in that location. With voice, that's a bit of a problem. Typically, the concept there is that certain branches, if not all branches for your location, need to be able to resume or to have voice service in the case of one of those WAN outages. And so one of the concepts we'll talk about today is what we have done inside of Lync to both enable this concept of branch resiliency and the services that can be provided in the case of those WAN or circuit failures. And then finally, we have the concept of Lync Online. We'll talk shortly about the capabilities and methods that we use to provide the concept of availability and resiliency in that area. Takeaways as we go through this, we're going to cover all the items that you'll be planning for, that you account for when designing either a highly available and or a site resilient Lync topology. And that's going to come into play with things like your RPO and RTO targets, your backup processes, your recovery metrics, as well as your operational awareness and your operational staff capabilities for things like 24/7 monitoring and alerting. So with that, let's start talking a little bit about our software development process. It was new to me. I've only been at Microsoft about 7 years when I came in to realize that when Microsoft ships a version of a product, it's not we start over and we start writing some code for the next version. The code bases for all of our software run, in many cases, for a decade or more. And so we release a version of a product, and we continue to iterate or enhance or build upon that. And every so many years, we will fork or ship a version of that product code. But the code base is intact, and then as that version ships, they're already starting the concept of planning what are the features and capabilities for the next version that's going to fork a couple of years later. In some cases, you may be aware that we announce maybe a version or a feature that will ship, and then it doesn't make it into that version. It's already on the radar for the next version. In other cases, we take those ship dates to sit back and look and determine what are some functionality or some capabilities that we would like to add in 2 years out. And then we take that existing code base and we start making changes to that to enable or to provide that capability or feature set that customers are looking for. In this case, and the reason I'm kind of highlighting that there, is we had to make a fundamental change in that core code base in Lync to achieve some of these capabilities, specifically around the concept of branch resiliency. And the major architecture change that we did there is really to separate out the user services component from the registrar component. In the past, going in the LCS and OCS days, you would register on a front-end server or a piece of infrastructure in OCS, and that infrastructure was also responsible for providing what we call user services. So registration is where you, as an endpoint, that could be your Lync client soft phone, that could be a voice over IP phone, for example, or some mobile device coming out later. But anyway, some endpoint that has your credentials, your SIP address, is going to register and provide a list of capabilities back to that registration point or the registrar. That list is going to include things such as your IP address or how to reach you, right? What ports you might be listening on, for example, as well as what services your endpoint provides. Do you have a laptop that has a webcam? Are you a voice over IP phone that simply has that voice workload or that voice capability? And so that information is stored or provided in that registrar component, and that registrar component then will accept or process these registration requests. In OCS, like we said, that was stored back in the main SQL database. So if you were on Standard Edition, that would be stored in SQL Express locally in the same area or vicinity as the user data or the user services component. If you're on Enterprise Edition, that was stored in the back-end SQL infrastructure. With Lync, we've taken that user registrar and provided that locally on the front-end server itself and removed it from that back-end SQL database. The back-end SQL database will still provide the user component, which is your actual presence status and any people in your buddy list, for example, right, or scheduled conferences that you may have, response groups that you may have set up. But the registration process has been offloaded and moved off to one of the front-end servers. And we actually store and process those registrations on a little copy of SQL Express on those front-end servers as well. Another piece of this is that all of your devices, due to the way we use our DNS load balancing algorithm, will registrar against that same front-end server in the infrastructure. And one of the differences about Lync is we can process multiple registrations. It's very common for me to be signed in on my voice over IP phone sitting at my desk at home, on a soft phone on my computer, and possibly more than one laptop in some cases as I'm working somewhere else or have another one. Some people at Microsoft will have 3, 4, or 5 registrations active at the same time. And the user component is going to determine which one's the most active, but we can process all those registrations on the front-end server in that infrastructure. But what this allows, and the reason we made this fundamental change of separating the registration process from the back-end database, is that now we have the capability of providing the registrar at a different location. And so now we can provide registration at a branch office type scenario. We can also do some other things that we'll talk about in the data center portion. But basically, this simplifies the registration process and removes the need for having that back-end SQL database and the user services component running at every location that we want to provide access for devices to register. So this concept then, you can think of these registrar locations as the concept of a pool, right? Our grouping of a collection of users inside of Lync would have this concept of the pool. The pool services are provided by this backend SQL database, but the registrar components are going to accept these registrations either locally at that branch office in SBA, for example, or possibly at the central location using one of these front-end server pools. If we do have a local registrar, or what we call a survivable branch appliance, running at a location, the default action for users in that pool is to register to that local registrar. And in that scenario, if we have a WAN outage, we don't have to worry about the client having to take some outage to start placing a telephone call or accepting a telephone call. That client is already registered locally. If that survivable branch appliance cannot reach the central location, the SBA can simply route that call out over a SIP trunk or over a PRI or an analog line that may be attached to that SBA or that branch appliance directly inside of that location. The other concept of this is that allows us to have the capability for an endpoint to have both a primary registrar pool and a backup registrar pool. And what this allows is us to provide a level of availability in the case of an infrastructure outage. So if we have a location failure, let's say it's a survivable branch appliance, and that SBA crashes, dies, becomes unavailable for some reason, the client already knows during the provisioning process, as we'll talk about in a moment, that there's a backup pool associated with it, and it can leverage the concept of registering natively to that backup pool without any user or server or administrator intervention. And so we have this sort of automatic failover process at the client that allows the client to have a primary registrar point and a backup registrar point, which allows that uninterruptible or the seamless sort of registration process to occur even in the case of a component failure. So let's take a look at how this works. We can see that we have the area in black, right, is our registrar component there. We can either have a hardware load balancer or a DNS load what we call DNS load balancing in front of that infrastructure. And when we say DNS load balancing, we're not referring to the concept of DNS round robin. What we're doing here is we're listing all of the DNS servers in your all of the front-end servers in your DNS infrastructure. The clients all have an algorithm where they'll look at all the front-end servers that are hosting their pool from DNS, randomize that list due to an algorithm, and then attempt to connect to them in that order. And so therefore, each client has a unique preferred method or preferred connection list of front-end servers in that pool, and we'll always try to connect to them in that sequence. That way we have an equitable distribution across all the clients to try to connect, and we remove the requirement for having another piece of infrastructure in front of those front-end servers to accommodate or to provide the capability for randomizing or separating those registration requests to different front-end servers inside of the pool. So in this case, we have a user. User's name is Bob. Bob is home pool, or his primary is Enterprise Edition Pool 1. So it's an Enterprise Edition, right? We can see that we have a separate SQL database on the back end that's providing that user component service for end users. We have a second Enterprise Edition pool. In this case, here's Alice's primary registrar is EE Pool 2. So we have two different pools in our organization. Those pools could be located in the same data center on a high-speed network. those pools may be geographically distributed. They could be in the same city in 2 different buildings. They could be distributed by, or they could be separated by thousands of miles. We could have one in Australia, one in Europe, one in the US, for example. We have no IP requirements around latency or routing between the pools inside of your infrastructure. For Alice, for example, her primary is EE Pool 2, her backup is EE Pool 1. For a branch, for example, right, we have the user Joe now. Joe registers directly against his survivable branch appliance. His backup registrar pool is also Enterprise Edition Pool 1. And so in this case, we've defined a backup pool for both Alice's and, or for the pool that Alice is housed on. The backup pool is EE Pool 1. And the pool that Joe is housed on, or his registrar that Joe is housed on, is the branch, and his backup pool would be EE Pool 1. In the case of a failure of either EE Pool 2 or the branch office, EE Pool 2 or the branch office, those clients would automatically connect back to their backup pool. We'll talk about what the functionality differences are there a bit later as we go through the pool resiliency. And in the case of a WAN failure, they would continue to work because we have actual infrastructure that they attach to directly at their location or near their location. We talked about the concept, right, of DNS load balancing. This is our, like we said, not DNS round robin, but basically the capability for clients to get a randomized list of the front-end servers in their pool, connect to the appropriate one, and use a consistent hash method that we can then use to identify what the preferred sequence order would be for any client coming inbound. We do have a note on there. We still require a hardware load balancer for the HTTPS protocols. So our native registrations using SIP can leverage DNS load balancing, but if you're using a browser such as Lync web app or other browser type functionality, we still require a hardware load balancer for that, as browsers currently do not have the capability of leveraging a DNS SRV record and the DNS load balancing capabilities provided in Lync. DNS load balancing does give you, as well as hardware load balancers, the capability to do what we call a drain stop, or essentially to tell one of the servers to stop accepting new connection requests. It will continue to accept, or it will continue to process registrations that are already in progress or users that are already registered. And as those users gradually sign off and or shut down or restart, eventually you'll have a lower utilization on that box, and you can go ahead and perform maintenance or do any other routine type of tasks without interrupting the work in progress that was existing on that front-end server. We also have, and we're not going to talk a lot in this session, but the concept of session dialogue resiliency. This session is all about the concept of client-to-server and server-to-server communications. Tomorrow afternoon, there will be another session on Lync in the enterprise network where we'll talk about some changes and improvements in Lync around keeping an actual audio session alive in the case of a network interruption or a loss of network connectivity, and the work we've done to change that. So we've got an hour where we'll talk more about the codecs used and some of the changes there around the session dialogue itself. And finally, one of the other things we wanted to do, and we'll talk more in the SBA scenario about this, but is the concept of caching. We wanted clients to be able to continue to connect even if there was a loss of Active Directory or DNS services, for example, inside of the organization. And so by caching the IP address, the FQDN and IP of their registrar pools, they're able to make that connection in the case of a failure or outage without relying on another system or process to be intact inside of the organization to be able to do things like name resolution. That also means that our reconnections are very rapid. We can pick up when that original pool is back online and make that reconnection back to the original. So the first main topic we'll talk about is the concept of branch office resiliency and give you a little more understanding of what a session, not a session border controller, a survivable branch appliance, or an SBA, is in the Microsoft Lync infrastructure. We have multiple options for that. The first one, or the simplest option, and we put numbers here. Don't worry so much about the numbers on the size. The only one that's important is 1,000. We recommend that SBAs not have more than 1,000 users. But we do see organizations put an SBA in for a site that has a critical reliance on voice with a small number, maybe 5 or 10 users, for example. But in general, we tend to see smaller locations. Customers are okay with not having resilient equipment there and relying on 2 WAN connections or a WAN connection with a backup local internet connection, for example, to provide that resiliency. So in the case of the loss of one of those circuits, you rely on the other circuit that's extended to that location, whether it be a dedicated WAN circuit or a local internet access, to allow that location to come back online or to continue or remain connected to the Lync infrastructure. Once we've decided that in the case of all network connectivity being cut or being down to the location, that we want to retain the ability to place and receive voice calls, at that point we start looking at two options for that location. The first one is the concept of an SBA, which is our simple deployment option. It's a hardware appliance. We'll show you how easy it is for a user or a person at that location to go ahead and put in some basic information, at which point it becomes functional for all users of that location and will run. A single chassis device. They're not looking at tape backups or server infrastructure or anything like that. So literally we're looking at a 2 or 1, 2, 3U device that's going to sit in a rack or in a closet and provide that capability for maintaining the user registrar component in the case of that WAN outage. And then the other option is what we call a survivable branch server or a standard edition server. In this case, we're actually going to provide some server infrastructure. Perhaps the location is large enough that we want to have that infrastructure there to house them, or that location does a lot of conferencing locally, and we want those conferences to be hosted at that specific location versus back in our remote data centers due to things like WAN connectivity and video conferencing and or desktop sharing bandwidth requirements, for example. So in this case, we're actually putting some Lync infrastructure in terms of an SBS or an SE server, as well as possibly a media gateway to provide that connection out to the PSTN in the case of that WAN or that circuit dropping between our local branch and our remote data center on the other side. The SBA, like we said, is a specialized appliance. We've worked with about a half dozen hardware vendors to come up with a specification for a survivable branch appliance, and it essentially runs a local copy of the user registrar component on Windows Server 2008 on a server inside of this chassis, as well as have some modules. These modules could accept connections such as a PRI interface, could be a SIP trunk, for example. It might be as simple as POTS lines or some analog lines running inbound, but essentially multiple options for PSTN physical connectivity into that SBA. That allows then, like we said, loss of a network connectivity back to the central region. Users are already registered there. That SBA will be able to route the traffic appropriately out to the PSTN or between users at that branch in the case of that outage. The real requirements here is the concept of voice and surviving that WAN circuit failure. If we don't have resilient WAN circuits or we're concerned about the reliability of our WAN circuits, the SBA is the way that we provide that voice resiliency for that branch office. The main pro that we see from the SBA side is there's no local configuration required here. Literally, it's giving it an IP address and joining the domain. From that point on, all dial plans, routing information, the gateways itself, the options for those users, 4- or 5-digit dialing, for example, is all going to be managed centrally. The SBA will read and pull that information from that central pool and the configuration options that you have defined, replicate it down to the SBA, and do that on a periodic schedule. So as you change information centrally, all the SBAs, as well as your pool infrastructure, will have all that information and keep it up to date. You won't have to go, if you buy an SBA from one partner for location 1, the second partner from location 2, and you have 6 different vendors providing your SBAs, you'll only have one change to make centrally. It will affect all those SBAs that you've acquired or are being provided inside of your organization. On the SBA, like we said, we do have some Windows Server components. And so we've got Server 2008 R2 with a mediation server, a registrar, and a PSTN gateway. What this means, and you're looking at that list, you're probably thinking to yourself, that means I need some sort of patch process, right? Obviously, whenever we have some software in place, especially complex software of this nature, we're going to have both bug fixes and security patches that are going to be released regularly by Microsoft that will need to be applied. We'll talk a little bit about what that process is in a moment, but we've worked that part out for you as well to give you some options there. On the gateway side, like we said, we'll have multiple physical connectivity options. The size and quantity of those is basically dependent on how much you're paying for the survivable branch appliance. So if you're running 800 or 900 users off of one of these and you need 1, 2, 300 concurrent PRI channels, you'll be buying a higher end SBA than if you're providing voice services and you need 20 concurrent PRI channels for the location. What do they look like? It could be, like we said, typically it's a 1 or 2U chassis device. We've got a couple listed there, right, from Audio Codes, Dialogic, Ferrari, and NET that essentially look like a small appliance. You're going to have some port connectivity for your connections off to the PSTN, a power switch, power input, and a module inside of there that's running that Windows component. HP actually makes one that sits inside of the ProCurve switch series. So if you're running ProCurve switches at your organization, you can buy an SBA module, that will slide directly into the ProCurve switch, and you don't need additional infrastructure at that location. How many of you here are running Office Communication Server 2007 R2? Anybody running R2? And do any of you have what we called an advanced or a hybrid gateway for the R2 infrastructure? So we started realizing this concept of mixing the mediation server and the gateway component to provide that single chassis for customers back in the OCS R2 timeline. What we did with the vendors that produced the concept of a hybrid or an advanced gateway is we provided an upgrade path to take that directly to an SBA via software and a firmware upgrade. So if you did invest in the Microsoft Vision a couple of years ago in the concept of a hybrid or an advanced gateway, the hardware vendors that have given you those have given an upgrade path to take that directly to an SBA without having to replace the hardware at that facility. So all the major ones, right, if you had that advanced or hybrid gateway concept in the R2 timeframe, you got a firmware patch from the gateway vendor, and that turned that gateway into a survivable branch appliance that would work with Lync. So deployment options, right? First thing you're going to do is order your SBA. You're going to go through some selection process and determine which one of the SBAs out there is appropriate for you. You'll then go ahead and update the master topology in Lync to reflect the fact that you're acquiring, let's say, one survivable branch appliance. So you'll define a name and an IP address in your Lync central management store inside of the organization. Go ahead and add it to the topology and start associating the users at that location with the SBA. So we can do all this now because we know the users have a primary and backup registrar. Their ability to log in won't be impacted even though the SBA is not available yet. At this point, we're going to go ahead, get the SBA, and either ship it to us, where we put in an IP address and join the domain, or ship it directly to the location, have a person at that location bring up a web interface, give it an IP address, join it to the domain, and at that point, your centralized configuration that you defined up front in Topology Builder is going to replicate down to your survivable branch appliance, and people who are associated with it, that you define to be associated with it, will start registering against that survivable branch appliance as they go ahead and sign into Lync, whether it be their soft phone running on their laptop or a hard phone that's wired into their desktop connection. For any changes, as we said, as you go through the traditional telephony business of changing extensions, phone numbers, dial plans, etc., all of those changes will be defined centrally in Lync in our central management store and will replicate both throughout your pool infrastructure as well as to any survivable branch appliances that you have on your premises. So no requirement as you change routing plans or dial plans to actually go through and reconfigure your device at each one of your locations to accommodate or to perform those changes. Finally, as we said, we understand that with Windows and with some of our services running on top of Windows, we're going to be regularly issuing security and patches, or security and bug fixes for the platforms that are running on the SBA. You have two choices. You can go ahead and deploy those updates yourself using your existing Windows Update or SCCM or other patch management solution that you may have, or you can rely on the gateway vendor to do that. And we're aware that in the past we've sometimes shipped devices or we've set up alliances with partners where we've said that the partner will provide the patch process and everything. But in this case, to be accepted to the gateway program or the SBA program, they actually have to commit to the timeline below. So prior to us shipping the patch for either Windows or for the Lync services running on top of Windows, we tell them 5 days before we publish the patch that a patch is coming. At that point, they have the time to go ahead and download that, begin any testing that they have. We then ship the patch off for our public and typical customers. they have 30 days to resolve any technical issues that that patch might have with their hardware configuration and issue any patches or updates to the firmware side on their gateway that may be required. If there's no issues, they can ship it earlier, but all of them have legally committed to shipping the updates that we provide within 30 days. So within 30 days, your SBA vendor will provide, of us releasing an update, the SBA vendors will also release the same updates, at which point you can ship a DVD to the location or do a software upgrade on the device to essentially upgrade its firmware and the Windows components to both our patch for latest versions as well as any firmware updates that they may have. So legally, they're obligated to provide that patch process. We haven't had any issues both in the advanced and hybrid gateway timeline as well as the current Lync SBA timelines with our patch capabilities under this process. We did mention early on that the user registrar component is separated from the concept, or the registrar component is separated from the user services component inside of Lync. What this means is that if you have a user running at a location and their primary registrar endpoint is a survivable branch appliance, at some point you will experience a WAN connection failure. That could be a planned outage where you're testing the capabilities. That could be an unplanned outage where there was an incident with the line. In either of those cases, when your user cannot reach the user services component, we have a subset of the functionality that will be provided. So in this case, what we're going to lose are the things that are in the user component. Your buddy list, right? Response groups, for example, or being able to do a data type session such as application sharing or a video conference with somebody back on the main pool. What we retain is our PSTN voice functionality. So things like inbound and outbound calling, calling an extension of a user at my location, for example, my basic call control of hold, receive, or transfer a call, authentication and authorization, which we'll talk more about in a moment, voicemail deposit and receive, right? Call forwarding, simul-ring, call detail records. All of these will continue to work while we're in that WAN outage type scenario. What doesn't work is our presence, conferencing, any changes to presence, for example, getting my buddy list, because those are stored in the SQL database that's back at the central location. So the SBA has the capability of maintaining the voice resiliency, but does not have that data connection back to the central pool location because that WAN connection is down. Once the WAN connection comes back up and that central pool is available again, these services will light back up. The way we address this from the user side is we actually bubble up a message inside of Office Communicator or Office Communicator Phone Edition, or sorry, Lync, the Lync client or the Lync Phone Edition client, which tells the user limited functionality will be available. So they're aware that they can place and receive calls, but they're with some training, or if they hover over that, right, they'll receive the information that their buddy list and some of these other data characteristics won't be available until that WAN connection is resumed. Any questions on what that user experience looks like in an outage or the separation process there? So I mentioned the concept of access and authorization. And you may be wondering, if I've got an SBA, how do I authenticate a user? Do I need DNS? Do I need a domain controller, right? What's the process that the user is going to authenticate off to one of these survivable branch appliances? Our goal is for you to be able to deploy this to locations that do not have name services capabilities or authentication capabilities. And the way we address this is by a certificate authentication process. So the first time a user signs into the question. What happens if they do have those services? We can. If they have, just because they have Active Directory or DNS locally, that would just mean that we wouldn't need to rely on the certificate caching, which I'll explain now. So the question is, if you have Active Directory or DNS, do you get any of the orange list, right? The orange list only comes up if you have a data connection to the SQL database that has the user services component. So my buddy list, my scheduled conferences, things of that nature. So not having the SQL database locally or available means that you're not going to get the features that are in orange. User first tries to sign in. The first thing they do is they issue a DNS SRV request. So obviously for the first sign in, we need that WAN connection to be available. They'll reach a DNS server. The DNS server will reply with their director pool FQDN if you have a director, or the front end pool if you don't have a director pool. We then go ahead and try to contact our SIP registrar endpoint. That's being provided back from the director pool or possibly a front-end pool, depending on what your SRV record will point to in your organization. The first thing that will happen is we'll then redirect that first request into a certificate provisioning request. When that happens, we then go out with a URL that requests a certificate from IIS on those front-end servers in the pool and replicate that certificate both to the Lync client as well as to the survivable branch appliance. So now we have a way to perform a private key public key certificate authentication in that location in the case of our central Active Directory or name server registration being unavailable. At that point, we then go ahead and try to register. The register request will hit the pool. The pool says, wait a minute, you are user Bob. In your case, your primary registrar point is actually the survivable branch appliance. I'm going to send a SIP 301 redirect back. That redirect will then cause the user to attempt to do a register to the SBA directly instead of the front-end server inside of that pool. We do a certificate authentication process there. We will cache the FQDN of that survivable branch appliance that we use, and we will have that information then in the future in case of a WAN connection outage or a failure of Active Directory or DNS to process that authentication request. So it looks like a lot of traffic as we do it all at once, but in essence what we're doing is ensuring that clients have the capability to connect locally even if we don't have name services or authentication services being provided at the location. We do update this certificate. I believe the default is 30 days, which is modifiable, right? But so it's not there for a year or 2 years or 5 years, and an old user can come in and regain phone services. But we do update this periodically, and we'll ensure that that certificate expiration time is recent enough to allow that to be a secure certificate authentication process in the location. So let's walk through what some of these registration scenarios look like for a user in a branch that has an SBA versus a pool infrastructure that's remote. First example, right, we've got a couple of users down at the branch office. When they submit their register request, that will go directly to the SBA. If one of the users in that branch office decides to roam and they leave the network, they're off at their home internet connection or a public internet connection somewhere, their request will come into the edge server infrastructure. The edge server will see that the user is associated with EE Pool 1, and that EE Pool 1, as that user, their primary registrar point is the SBA, their registration request will go directly off to the SBA. So even when the user is coming in remotely, their primary registrar point will always be that survivable branch appliance. In the case that the WAN connection drops, the users at the location will continue to operate. They have a registrar endpoint that's at their location. It's reachable. They will perform their default registration. A user externally, however, has no way to access the SBA because the WAN connection is out. That request will come in through the edge server. That request at the edge server will attempt to contact the SBA. We will have noticed that the SBA is down. We've got a timeout period we'll talk about in a moment. And it says, in this case, I will use the backup registrar point, which is the actual front-end server pool infrastructure. Go ahead, register. In this case, the edge user has full services. They're talking to a pool that has all of their user information. The branch office users have the green list, right? They have PSTN connectivity only because they don't have a data connection back to that SQL Server infrastructure. In the case of the SBA failure, but the WAN is still available, the users will register over the WAN back to their backup pool. In this case, they retain all services because they have access back to that core SQL database that has all their user services component. So the edge, the public internet user, as well as the branch users, will have that functionality, full functionality, in the case of that SBA failure. Any questions on the question? Sorry? What about incoming PSTN? Excellent question. So typically, you'll have a central office and a branch office. The branch office is probably located on what we call in the US a separate exchange, meaning it has a separate prefix associated with that location. When you set up your central office, you typically will have the phone numbers incoming to the central office for all the users in your organization. You may also break out incoming at the branch to go through the branch. But let's assume at this point that all phone numbers are routed centrally first from the PSTN to your on-premises infrastructure, and then for the branch users are routed internally down off to the SBA. In the case of a WAN failure, the telco does not have an awareness or a way for us to signal an awareness electronically that you've had a failure of your WAN connection. So in the WAN connection failure, in the second example, incoming calls will all ring to our central pool infrastructure. The users who are at the branch appear as offline. They don't have a way to register back, and so their calls will divert to voicemail. If this is a short-term outage, that may be tolerable, but if you're aware that this outage may take 2, 3, 4 days, you may want to take a workaround, or several hours even, for example. It's common in the US, I'd have to ask the Australian telcos if it's possible here, for you to have a backup interface for a subset of your incoming numbers. And so in that case, you would go to the telco website, or you open a ticket, for example, that says, I'm experiencing a WAN outage. It's going to be 16 hours in duration. For that time period, I would like you to reroute incoming calls for that branch to the backup to the SBA located at that branch office facility. So in that case, they would have incoming calls for the branch, but they wouldn't have voicemail because their voicemail services are central. So you have to make a choice of whether you want the calls incoming to go to that branch location or not. Another common scenario is that a company will associate a handful, maybe 5 or 6 DIDs, such as a main office number and a backup pool, for example, that allows people to call the branch or the central office to forward calls to that branch office. One person there would take the calls and route them appropriately inside of the branch office. So in essence, what happens in the WAN failure is if your numbers are coming in centrally, telco has to be made aware that you've had an outage in your network and you want to reroute some of those incoming calls down to the branch office. This is assuming that your branch office location has no separate internet access path. One of the main changes for Lync or from Office Communications Server Right is the capability for the clients to register directly with just an internet connection. So if they can register with an internet connection, they would use the internet connection as their backup WAN link essentially, register back to the pool. They're now an active client. Inbound and outbound calls will continue to work through the main office location using that backup internet connection. But you will have to go through the planning process of A, are you routing all numbers to your central location and then have a fallback solution for the branch, or have you split out your incoming calls to have incoming defaulting to the actual location where the user is housed? So it is going to be telco specific in that case of what your choices are. So let's talk about the concept of what happens right when that WAN connectivity drops. We know that we have the capability of caching the FQDN and IP address. Client's going to talk to the SBA. At that point, SBA will come back with a valid registration. We know what the certificate has been placed on both Bob's computer as well as the SBA, and we can perform that authentication. The next 4 slides or so will walk us through the concept of the differences between the signaling path and the media path. So in these cases where we have failures, such as a WAN failure or an SBA failure or a pool failure, we're going to have some differences in the way the signaling works versus the media flow itself. So normal operations, right? Users in the branch location, the signaling path will flow through the SBA. Media, voice or video or conferencing, for example, is going to flow peer-to-peer between the users at that location. This is for a two-party call, any two-party call. Conferencing, of course, is going to have to flow back through the pool infrastructure, as that's where our conferencing MCUs would be located. A branch call that's going to go out over the PSTN, you have a choice. You can either have that call flow back across the WAN and exit your PSTN gateway at your central site, or you can have that call route directly out over the PSTN infrastructure at the branch location. So signaling again will go device or the client to the SBA. The media flow is going to be up to you. In this case, we're depicting the sample of you would route directly out the PSTN. Common in this case to save, for example, toll charges inside of the organization. We could also have your central pools that dial a number associated with that location routed to the branch to exit that PSTN as well. So you'd go through your normalization rules and your call routing rules to determine when do you use the local outbound gateway and when do you use the central outbound gateway. Now we have a user in the branch that calls a user inside of the central location. User in the branch, a signaling path will go to the SBA. SBA realizes that the recipient is not local, but is back at the central office and will then send the signal back to the front-end server pool. Users on that pool, we talk directly to the client. Users on a different pool will send the signaling off to that pool to find the client's registration information and eventually establish a signaling path directly to the client. Call flow or media is going to be peer-to-peer again, client to remote client crossing the WAN, but no media flow through the gateway or through the SBA or through our centralized pool infrastructure. We have a branch user who's on the internet, right? That could be a user in the branch with internet access. That could be a user out on the public IP network, for example, coming in over the internet. Signaling, as we know, is first going to flow through edge. If the SBA is available, that signaling will talk to the SBA. If the branch user is calling a user centrally, the signaling will flow back to the pool, find the user. We've established a signaling path. At that point, call flow will be client through the edge server infrastructure to the user who's internal in the central office. And intra-branch calls, right? In the case of a WAN scenario failing, client will register to the SBA. When we place a call that's local, we will call the registration path or media signaling path will flow out to the SBA, SBA to the other client at that location. Call flow will retain as peer-to-peer. We will do the call from the A party to the B party, local in the location. Both clients in this case are registered directly to the SBA, so we're aware of what the IP address is for the remote clients in that organization. Inter-branch calls, but the WAN is down. Signaling will go to the SBA, but we can no longer send a SIP signal back to our central pool. We don't have a data connection in this scenario from branch office back to our pool infrastructure. But we have a PSTN connection on the SBA, so we can send our signaling out to the PSTN. Signaling will come inbound through a gateway or a SIP trunk to our pool infrastructure, find the remote client. At that point, we will have a separate media path as clients will send the media to the SBA, route the media through the PSTN, and eventually through the gateway, through the gateway directly to that endpoint that's in the central office. So signaling path in this case is going to follow the media through the PSTN from the gateway to the central office. And finally, the external user's right, WAN connection is down. External user will register to their backup pool, which is available centrally at the location. Signaling edge server into our front-end pool. Media path or the call flow will go client to the edge server to the computer or the device that's the endpoint in that central pool location. SBA down, clients will register to their central pool infrastructure. Call flow will remain peer-to-peer for clients inside of that scenario. Any questions on the branch office resiliency options of survivable branch appliances, how you deploy one, or what the call flow would look like in those scenarios? All right. So the next one is this concept of data center voice resiliency, or the capability of providing high availability or site resiliency for our infrastructure. At Microsoft, we spent a lot of time over the past decade learning quite a bit about how customers operate systems and how to make those systems highly available. One of the principal rules that we learned is to break out from the concept of relying only on single points of failure. If you go back 10 years, all of our high availability was provided by the concept of clustering with shared storage. And so we would have a cluster that was running on NT4 or Windows 2000 or 2003, and we'd have services that would run on that cluster. And those services could be Exchange or SQL or other applications, for example. But what we found is that when we relied on a shared storage infrastructure, we essentially had a single point of failure. And over time, outages or an impact on that single point of failure would cause all services riding above it to fail as well. And so we realized we kind of had to break out from the concept of single points of failure in our design plans or our architecture plans as we're developing software. The main corollary here is we have to have at least two discrete options when we're really providing high availability. We can do a partial or a modicum of high availability when we have a single point of failure, but we don't really start to obtain high availability until we have a full separation between services being provided from this pool or set of servers, for example, and this pool or this set of servers or this individual server. You see this, first of all, with Active Directory. What you have is, if you saw the session this morning, right, the kernel, or Robert Gillies calls it a man and his dog. A server plus some server plus some locally attached storage is a very simple unit that you can then deploy software on. There's software replication that will take the changes to the different servers in the organization, and as a result, we expect failures. We can take a domain controller down at nearly any point during normal operations, and we will have a limited, if any, impact on normal operations in that environment. So as we distribute the load across multiple instances of domain controllers, we can take an outage hit of maintenance or a unscheduled outage, but the Active Directory service remains operational. You saw this in the Exchange side, starting with Exchange 2007, with the capability of having software replication. So now we have two Exchange servers, an active and a passive node, right? Software replication. Either node fails, the Exchange service itself stays up and running. Exchange 2010, we've extended that again, same concept. We call it a database availability group. It looks a lot like a domain from an architecture perspective. Multiple servers configured identically. Any one of those fails, the pool or the database availability group essentially stays maintaining or stays operational. With Lync, what you're seeing now is this capability being extended to Lync for the first time. And so with Lync, inside of a pool, we have the capability of providing high availability. And so high availability is the concept of multiple front-end servers in a pool, a single back-end SQL server providing the data services. And we looked at that, and no matter how we structure it, no matter how robust our operations are around SQL, a single pool just isn't going to provide us high availability because a SQL operator error or a shared storage error, administrator error, is going to take or cause an extended outage for the service at that time. And so, with the split of that registrar component from the user services component, we can take the same concept we leverage with an SBA and extend it to our pool infrastructure, in essence allowing one pool to completely fail, but having some services survive that failure automatically and continue to operate. From a backup pool capabilities, right now that's limited to voice. We put our investment in the Lync time frame into providing this high availability capability around voice particularly. There was a high emphasis on voice, and having voice survive these kinds of typical either patching or operator errors or administration or hardware failures in an organization, yet ensuring that that overall voice service survives. And so what we don't have in the pool level failover, right, and we'll see this as we walk through a little bit, is the concept of an IAM and presence, so your buddy list, or conferencing failover yet between those pools via an automatic process. And we'll try to cover that a little bit more. So in essence, though, what we're saying is that in Lync, your core availability starts when you have two pools or two distinct areas that can provide user services, and one is a primary and one is a backup. You can go with 100% and 0, or what we like to call the 50-50 model, where 50% of the users are on pool 1, 50% are on pool 2. A failure of either pool means that half of the users in your organization now have limited functionality, meaning they have voice connectivity, but the other half are completely not affected, right? So you restore that original pool, or you take some actions to resolve the services for the users who are affected, and you're able to bring back full availability inside of the organization. This concept comes from the capability of software replication. Every Lync server in your organization is going to have the central management store or a copy of the Lync topology and Lync configuration. Therefore, every server can survive essentially without having to contact a remote or central pool or a central database to run or maintain that operation. So a pool failure in this scenario, the other pool is already aware that it's a backup pool for those users. Once it determines that that primary pool is not available, the backup pool will begin accepting these client registration requests and allow clients to connect. So looking at this concept of two pools will look very, very similar to the concept of the survivable branch appliance and the remote pool in a separate data center, except that in this case, we have a full set of services being provided on each side. So here we're saying Berlin and Singapore. We have two Enterprise Edition pools at these locations. A common question is, do you need Enterprise? Pool level failover works with Standard and Enterprise Edition. So you can have Standard servers in the Berlin data center, Enterprise Edition in Singapore. You could have Standard in both. You could have Enterprise in both. It doesn't matter which licensing version you've chosen for your Lync services. So user boots up in the Berlin data center, or I shouldn't say boots up, a user who's housed with their primary pool in Berlin, boots up, it does a DNS query for their SRV record, they get the response for the director pool, they talk then to their front-end server pool, they submit their registration request, they're going to learn what their primary and their backup pool infrastructure is. They will register to their primary pool. If their primary pool then is ever not available, they will attempt to register to their backup pool. And so the client has this logic built in. You don't have to take any steps or any actions to provide this capability for clients to connect to their backup pool. In the case of a failover right to the backup data center, same concept. In the failure scenario, clients will just automatically connect to the pool that's running in the remote data center. Both of those pools could be in the same data center. In that case, you'd be providing that pool level failover in the same. The pools, however, scale to relatively large sizes in the 60,000 range to 80,000 range. So it's typical for us to see a single pool for a data center. We have seen customers deploy more than one to provide that capability of pool resiliency or to provide the capability of simplifying, for example, their SQL operations. In the case of the failure scenario, what you're going to see is a similar list of what's possible and not possible in the SBA scenario. The voice capabilities will survive. So in this case, the users who are housed in Berlin as their primary, in the outage of the Berlin data center, those clients will connect automatically to their backup pool. They'll get the same little pop-up inside of the Lync client that says limited functionality is available, and they'll be able to place, receive calls, for example, right? Do their call controls such as hold, receive, transfer, call forwarding, other voice-related functionality. What they don't have is the capability for conferencing. Their scheduled conferences are sitting over here in the SQL database on their primary pool. And in Lync today, right, we're not automatically replicating that user portion between pools. Today we're only replicating the voice plans, your dial plans, normalization rules, etc. from pool to pool today. The conferences, as we said, are located there. They're changing their call forwarding settings. Their call forwarding settings read-write replica is on their primary pool. Where's my... There we are. But we know what their call forwarding settings are, and so therefore call forwarding will work, it just can't be modified. Response groups, again, associated on that primary SQL storage infrastructure. And depending on your Exchange configuration, right, your voicemail deposit and voicemail retrieve will be unavailable as well. Now what we say here a little bit is that today, right, we're not replicating this information automatically from your primary pool to your backup pool. But this content is relatively small. We're talking, a few dozen megabytes, maybe a couple hundred megabytes in a larger organization, high-end, a gig or two. It's very simple, and we've got a few people doing this, and we're working on a blog posting for it. For you to write an export script, that exports your user configuration from pool 1 and puts it on a file share or on the SQL server on a file share somewhere over in the Singapore pool in data center 2. What that means is that in the case of a pool failure, and it will be down for more than an hour, for example, let's say, you can then rehome the users to have their primary pool of Singapore, import the data that you've exported on an hourly basis, for example, and conferencing, presence, voicemail deposit retrieve, response group editing, all that functionality will be restored for the users. So we have automatic voice failover, and we have the option for you to do a manual administrator-led failover for the other services such as conferencing, buddy lists, and response groups. So the capability exists, but you're going to have to do the export and do the import in the case of that pool level failover. Yes? Yep. Yes, the question is, let's take this scenario, right, where we do a manual export and we have the file sitting there locally. The first thing is before we can run the import on EE Pool 2, we have to force move the users to EE Pool 2. That will create entries for them in the SQL database on that second Enterprise Edition pool that could then be populated with the data that you've exported. So first step is to obviously have the exports running, right? So you have the exported data or the backup available. Second step is to go into your user configuration and say, for all the users who used to be in Berlin, force move them to the second pool in this organization. Third step is then to import their data back in. All of a sudden, their buddy lists appear, their conferences are ready, they're able to resume service as they normally would. Once the Berlin data center comes online, we can then move the users back. Both servers are online, so it's possible for us to just rehome the users essentially without going through the similar sort of brute force attack that we did for the initial failover. Question? There is data in the database on the other side. We'd want to overwrite that with any new changes. They probably modify, or they may have added new scheduled conferences. They may have modified their buddy list, for example. We're going to take some steps to ensure that when we do the move over, that we move the new information over to that original pool. There is a clear process on the other side that is covered as well. Yep. There's some steps involved in bringing up the original. So if we're bringing up the original source infrastructure, we'll take some steps to make sure that when it comes up, users don't register to it. We can run the clear process as you're alluding to. The question is, let's say it's a simple power outage failure in the first one, and we know that is restored in 2 days. We go through our rehoming process for the second pool. We bring up the first pool. We isolate out or remove the users from that one, right? So essentially, they're not present on that infrastructure anymore, and then push the users back. So we're developing the full process. We've run this at a couple customers for testing already, and as we complete that, we'll publish that out for you to have this pool level resiliency with the administrator fallback or failover process between them. Question? The question is, where's the home number for an individual user? The user attributes for Lync are stored in Active Directory for backwards compatibility. We also store a copy of them in that central management store and replicate it between the servers on each side. So it's actually in both locations, essentially, and therefore that information is already present. And that's why we have the voice routing and the voice not just their home number, right, but also their dial plans and normalization rules are at both locations prior to the failover, which is why voice automatically works in the pool level failure mode. As we address the other scenarios, right, eventually, ideally, you won't have to take these steps for the conferencing, response groups, and other services. We'll obviously tune that over time. But for now, it's voice plus manual for other services. Yes? Yes. So question is, what do you do for the PSTN connections inbound and outbound in this scenario? You've got a set of numbers associated with Berlin and a set of numbers associated with Singapore. It's going to depend on your carrier in this case. What we are seeing is the establishment now of global carriers, which can actually fall a set of numbers or fail a set of numbers in a SIP trunk to 2 different IP addresses, which essentially means that we have a SIP trunk from our global carrier, and we can have those numbers automatically fail over to an IP address at a second data center. That IP address can be located anywhere in the world. So in this case, we're showing Berlin and Singapore, but we have several deployments of this in the US where we have 2 separate pools, a carrier in the US that sends numbers into location 1. If that IP address is unavailable, those calls are automatically directed to the backup inbound entry point, which is a second data center with a separate pool infrastructure. Both sides are configured to accept the SIP trunk, and so therefore in normal or in disaster operations, users have full inbound and outbound voice calling for all the the numbers associated with that SIP trunk specifically. What you will have to check is, can you get ranges for your location ported between either 2 data centers in the same country or potentially 2 data centers in different countries. All of those would have a potential fee, obviously, associated with it. But the capability for number failover between data centers exists with the SIP trunk capabilities from telcos today. So, you may be asking, well, I don't want to do this. I like the concept that Microsoft had provided an automatic voice failover experience, but it sounds like you guys have some bit of work to do there around, or that I might have a bit of work to do, right, around this manual failover experience. You'll write something up for us, we'll go through and test it on an organization, but it's going to require someone pushing a button and someone executing a script or process to provide a recovery or a full recovery for the users in case of that scenario. With Office Communication Server 2007 R2 and continuing to be supported with Lync is the concept of what we call metropolitan data center resiliency. In essence, in this case, we're taking a pool and we're actually splitting that pool across 2 physical locations. We have a SQL database in the primary that's an active, and a SQL database in the secondary, which is passive. And we will fail over the SQL instance to the secondary data center in the case of any outage in that primary data center. The Metropolitan Data Center Resiliency does not have the orange list, right, of what works and what doesn't work, because essentially both the registrar component and the user component are to fail over. That SQL database fails over. So the other side is going to retain all of that functionality. This sounds very interesting, and you probably want to read a lot more about it until you start to read some of the technical requirements for this. First one is we require synchronous data replication from your storage vendor for that SQL database. That is a significant hurdle for some organizations. It can be quite expensive to put into place a synchronous data replication system. This also has a latency impact. We don't support more than 20 milliseconds between the two data centers. So we're no longer splitting this between a Berlin and Singapore type scenario. This is typically within the same physical metropolitan area or same geographical location. Keep that latency number under 20 milliseconds. We sometimes will call that the two-floor scenario. If you have two data centers in the same geographical location, you may even have 1 millisecond, 10 millisecond ping times between that. Essentially, you have the choice of creating one Active Directory site that happens to span two separate buildings. If you've got an infrastructure that looks like that, you can deploy Lync on top of it with that automatic failover experience. In that case, we're going to allow or enable the full both voice failover plus conferencing plus response groups plus IAM and presence in your buddy list in the case of that data center failure. The only thing that may not be available would be Exchange, and that would be dependent as to whether or not you've also configured your Exchange infrastructure to be present in both locations and have the server role present in both locations to accept those inbound voicemail calls or voicemail deposits. So if Exchange is present in both locations as well, we're going to give you a complete data center failover scenario limited to that metropolitan geographical area. And we've got that documented. We've got the link down at the bottom for you. I'm looking to see what, I think I covered the data replication, low latency, geographically dispersed SQL cluster. Finally, getting towards the end, right, the last one will be the concept of backup and restore. We're also going through, and we provided a link out here on TechNet of what do you do for backing up and restoring Lync. You're aware that the configuration for Lync is spread out across all copies of the Lync servers. All of them will have a copy of the CMS or the central management store, the topology and configuration of Lync. But we also have these things such as people's buddy lists, the response group configuration, and other user services that are being stored in SQL. That's the type of data that we're talking about being backed up. That ensures that you'll have that in the case of a SQL Server database failure. You can restore that into the existing database or possibly restore that to a different pool infrastructure once you've rehomed the users to the secondary pool. So that sums up our Lync server high availability and site resiliency. We tend to sum it up with a quote from a company called Mircom. Does an exhaustive set of UC/PBX voice tests. Mircom ran a test. This is downloadable on the internet. We've got a link inside the hidden slides here later. But essentially saying that they're able to generate 4 million calls against Lync without any memory leaks, degradation of service, or any substantial problems. And it was essentially the first time they've ever ran a load test of that scale against a UC product versus a traditional PBX, and haven't seen that scalability, memory leaks, performance issues, security issues, etc. inside of that solution. So we were proud to see that. Like we said, we were also proud to see that Gartner has recognized your efforts in this area as well. We'd like to leave you with that concept. So at the end of the day, you've got multiple options for resiliency. The first one is the basic concept of what do we do in the branch scenarios. Survivable branch appliances are our recommendation for ease of voice resiliency in those locations. And then you've got the concept of what to do for your core data center services. And essentially you have two choices. One of them is the concept of two pools, whether it be the same data center or a separate data center, so you have a primary and a backup. The other option would be the concept of a metropolitan data center resiliency option where you want full automatic failure. The main difference, like we said, is what's automatic and what's manual today. We're targeting, I think by the end of the year or so, having that documented the process for the scripted admin pool failover experience of how to bring users from pool 1 over to pool 2. Which also brings up at the end of the day, I talked about you can do pool level failure for standard and for enterprise edition, right? But the simple solution then will be 2 standard edition servers with the scripted process. We do some work there on SQL Express, but that would give the simplest multiple pool Lync failover component. So with that, we'll take any open questions and ask questions on site resiliency, high availability, any of the Lync changes from previous versions. Yes? So is the question, you've got 2 A party and the B parties at the branch. You're starting with, it's a question about an SBA, correct? Yep, so two locations at the branch. Or I'm sorry, yes. Okay. Correct. Yes, so if branch A and branch B both have WAN connectivity, user in branch A has an SBA. Let's say user in branch B is just housed back to their main pool. Signaling traffic will flow user to A party to the SBA to the pool to the B party. Media traffic is going to flow A party directly to B party, because as long as you have IP connectivity without any firewalls between your endpoints, we will have a peer-to-peer media traffic regardless of where in the network infrastructure they're placed. Could the media traffic flow to a telco or SBC for a user in branch A calling a user in branch B? User in branch A calling somebody on the PSTN. Your choice there is, so signaling traffic will go user in the branch to the SBA at the branch, and you now have a choice. You can either have the signaling go directly out the PSTN to the end user, or you could have the signaling go back to your central pool infrastructure out a separate gateway. And typically, you'll make that decision based on a routing decision of who is the B party being called, and where is it cheaper for that call to exit my infrastructure to go to that B party. Is it cheaper for them to go out the branch PSTN and PSTN all the way to the recipient, or is it cheaper for me to cross the WAN to a gateway that has a lower toll charge to get that B party and exit at that central or even another branch that has an SBA? So you can exit the call, I guess, anywhere on your network where you have PSTN outbound connectivity, and you'd make that decision as a routing decision centrally. And it may be different based on users and other factors, but the media flow in that case would leave wherever you dictated on your network to leave and reach the PSTN. Does that answer the question? Yep. Oh, yes. I think where you're going now, I think, is what we call, So signaling traffic in this case is going to leave. We've defined a SIP trunk centrally. We prefer outbound calls to flow through that. The media is not going to flow through the SBA unless you're exiting at the gateway to the PSTN at the SBA. If the call flow is to a PSTN user and we route that back through our central Lync infrastructure, signaling will go client, SBA at that location, central branch pool, where it says, it's actually the SBC at that central location. So signaling would go that way. Media path would go client to mediation server centrally to that to the SBC outbound. So it won't touch the SBA on the way out. I think, I see Brandon smile. Correct me if I'm wrong, guys, but we can't do media bypass to an SBC correctly in Lync. Does anyone know that? From the Microsoft guys, and they're shaking their head no. So it has to cross the mediation server outbound on the way out. Pardon? On the SBC side? Yeah, it's kind of gray, right, as to whether or not the organization requires. Question was, does the SBC do RTP or SRTP? And we see that as from the U.S. side, organization decision more than anything else. Excellent question. So how does Lync Online address high availability and site resiliency? So one of the tenets, right, of our online services portfolio is it must be low cost. We have to have a low monthly cost for the services being provided. Lync Online, as well as BPOS for Office 365, uses standard edition servers across the board with an export-import script to provide availability. The assumption is we can restore capabilities within about 15 to 30 minutes on our scripted process, and so therefore we don't need any of the additional cost or infrastructure. So it's the simple model. So it's a standard edition across the board. Anything else? Well, if you have any other questions, come on up over at the end. But thank you for coming out and learning a little more about HA and site resiliency.